So alkanes are hydrocarbons containing only single bond, point number 1. Point number 2, they have the general formula CnH2n plus 2, where N refers to the number of carbon atoms. Using this chemical formula, we can derive the different members of the alkane family, and these are less reactive because they are saturated. Let us look at alkenes. Alkenes are hydrocarbons containing double bond. So if there is a hydrocarbon where you find a double bond, then it is a alkene. So there should be a double bond where the double bond is present between the two carbon atoms. Very important point. Containing double bond between the carbon atoms. So there should be double bond present between the carbon atom. Such hydrocarbons are called as alkenes, whereas alkanes contain only single bond. What is their general formula? The general formula of alkanes are CnH2n, where once again N refers to the number of carbon atoms, and in this case you see that the number of hydrogen atoms are exactly double the number of carbon atoms by going by the general formula. So let us now write down the members of the alkene family of hydrocarbons. Remember, there should be a double bond between the carbon atoms. So let us start with writing the first member by replacing n equals to 1. If n is equals to 1, then we will have 2 into 1 is 2. So the formula will be CH2. But we cannot have this compound. Why? Because there is no possibility of a double bond. Clearly it says that there should be a double bond because there is only one carbon atom and hydrogen atom. Double bond is impossible because valency of hydrogen is only 1. So the first member of alkene is not this compound. This compound is absent. This compound is not possible. Let us check with n equals to 2. If there are two carbon atoms, C2H2n, 2 into 2, formula will be C2H4. So maybe this structure is possible because there are two carbon atoms. So let us write the structural formula. 2 carbon atoms written in a straight line. Second important point, because it is an alkene, you need a double bond. In alkanes we put a single bond. In alkenes we put a double bond. Next, we have to add the hydrogen atoms. There are 4 hydrogen atoms. This carbon, its valence is 2 because it is sharing 2 pairs of electrons already with this carbon. So it can take 2 more atoms to complete the valency. So it can take 1 hydrogen, it can take another hydrogen. By doing so, the valency of this carbon is 4. 1, 2, 3, 4. So this carbon is stable. Similarly, this carbon can also bond to another hydrogen and the valency would be 1, 2, 3, 4. So all tick marks, which means this structure is correct. There are 2 carbon atoms, done. There are 4 hydrogen atoms, done. There is a double bond, done, and the valency of carbon is 4. So what would be the name of this structure? Any hydrocarbon containing 2 carbons, it begins with eth, as you know. Because it is an alkene, the name will end with the ene. So its name will be ethene. That is the first member of the alkene family. There is no methane. That is not possible. So the first member in the alkene family is ethene. Here you have to pay extra attention to your handwriting, because just a and a E will change the entire answer. So your A's and E's should be properly written. Better to use capital letters when writing the names, so that there is no confusion. So this is the first member of the alkene family, that is ethene. Let us look at a question, a possible question. A hydrocarbon containing a double bond has 3 carbon atoms. It's a hydrocarbon. It contains double bond. It has 3 carbon atoms. Write the chemical formula and structural formula. Name this hydrocarbon. So it is a hydrocarbon, which means there is only carbon and hydrogen. It has a double bond, which immediately tells us that it is alkene. And they say that there are 3 carbon atoms. So N equals to 3. So you will get questions like this most probably. So N is equals to 3 means the formula will be C3H6. Alkenes will have double the number of hydrogen atoms as opposed to carbon. So there are 2 carbon, there is 4 hydrogen. 3 carbon, 6 hydrogen, because the formula is CnH2n. This is the general formula. So let us write the structural formula. There are 3 carbon atoms, 1, 2, 3. Then there should be at least 1 double bond present between the 3 carbon atoms. So let us say I put a double bond here, and just to show you, I am putting another double bond also here, because you know alkenes should contain double bond. They should contain at least 1 double bond. So I am putting 2 double bonds, and next we have to add 6 hydrogen atoms. Can we write the structure? So this carbon valency is already 2. It needs 2 more. So let us add the hydrogen atoms here. This carbon atom, it is already completely stable. Why? Because 1, 2, 3, 4. Its valence is already satisfied. So you can't add any hydrogen atoms here. Then we have this carbon atom. So this carbon atom also, it has 2 valencies occupied. It requires 2 more valencies. So we can add 2 more hydrogens. And automatically you can see that this is not the correct structural formula for C3H6, because there need to be 6 hydrogens, but there are only 4 possible. So how to add the remaining 2? So we can simply do this by removing one of the double bonds, this or this, anyone. So I remove this double bond for making this structure possible. So alkenes means they should contain at least one double bond. So one double bond has to be there, that is enough. So when I remove this one double bond, then now you can see the first carbon, its valency is 3. 1, 2, 3. It can take one more hydrogen. The second carbon, its valency is 1, 2, 3. So this needs one more hydrogen. Now we have added 2 hydrogens. Count the number of hydrogens. 1, 2, 3, 4, 5, 6. 6 hydrogens are done. Carbon atoms are 1, 2, 3. Check whether there is a double bond. Yes, there is one double bond, which means it is an alkene. And check the valencies of carbon, whether the carbon is bonded to 4. 1, 2, 3, 4. Check. 1, 2, 3, 4. Done. And the last carbon 1, 2, 3, 4. So now the structure is correct. That is how you cross check. So writing of structures is very easy. What would be the name of this alkene? Because there are 1, 2, 3 carbon atoms. 3 carbon atoms means the name will begin with the prop. And because it is an alkene, the name will end with the ene. The name of this structure, hydrocarbon, will be propene. Similarly, let us write one more structure. This is the second member in the alkene family, that is propene. If there are 4 carbon atoms, then the formula would be C4H8. Join all the carbon atoms, and in the previous case we already saw that only one double bond is sufficient. So we can put the double bond wherever you want. So I put it here in the final carbon, one double bond. It makes it an alkene. Then you add with your hydrogen atoms. So I have put it to the last carbon, the double bond. So it needs, this carbon needs 2 more hydrogens. 1, 2. So this valence is check. This carbon is bonded to 1, 2, 3. It can take one more valency. So one more hydrogen atom will fit in. This carbon is bound to 2 carbon. It requires 2 more valencies to be satisfied. So we can put 2 more hydrogen. And the last carbon, it is bound to only 1 carbon. It can take 3 more hydrogens. So count the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen atoms are check. There is a double bond, check, and the valencies of carbon is also 4 everywhere. So the structure is correct. And what is the name of the structure? Because it contains 4 carbon, the name starts with the but, and because it is an alkene, it will end with the ene. So the name of the alkene containing 4 carbon atoms is butene. Now you may have a question. What if instead of putting the double bond here, if you put it in between these 2 carbon, is the structure possible? Because this carbon and this carbon is same. There will be no change. If you put a double bond here, what would happen? Let us check it out. So let us try that. So we write down the 4 carbon atoms and let us put the double bond in between these 2 carbons. Then all we have to do is fill in the hydrogen. This carbon requires 3 hydrogens. This carbon requires 3 hydrogens. then this carbon is bound to 1, 2, 3. It can take one hydrogen. This carbon is bound to 1, 2, 3. It can take another hydrogen. So check the valencies of carbon. 4 here, 1, 2, 3, 4 here. This is 1, 2, 3, 4 and 4. So this is also possible. And check the number of hydrogen atoms: 3, 6, 2, 8. This is also possible. So similarly, you can practice writing the structures for alkene containing N is equals to 5, 6 and 7 carbon atoms like you did for alkane. So that is all about alkenes. Let us move on to the third type of hydrocarbon, alkyne. Alkynes, the naming ends with the "ine". These are hydrocarbons containing a triple bond, containing one triple bond at least, containing triple bond. So there should be at least one triple bond for the hydrocarbon to be called as a alkyne. And the general formula of alkynes are CnH2n minus 2. This is the general formula for alkyne. So in this case, alkenes are CnH2n plus 2, CnH2n, CnH2n minus 2. Let us quickly write down the structures possible. As you know, in this case also there should be a triple bond between two carbon atoms, which means the first member is not methyne because one carbon is not possible. So let us start with N equals to 2. Then we will have C2H, 2 into 2 minus 2, 2 into 2, 4 minus 2 is 2. So the formula for the first alkyne may be C2H2. Let us write the structural formula. Write down the carbon atoms. There are two carbon atoms. How will you join them? Because it is an alkyne, there has to be a triple bond. 1, 2, 3. So there it goes, and we need two hydrogen atoms. Where will you add them? Both carbons, 3 valencies are filled. They require 1 hydrogen each. And the structure is complete. There are 2 carbons, 2 hydrogens. There is a triple bond, and the valency of carbon is 4 everywhere. 1, 2, 3, 4. 1, 2, 3, 4. All check marks, which means the structure is correct. And what is the name of this structure? There is 2 carbon, means it begins with the eth, and because it is an alkyne, it will end with the yne. So the name is ethyne. That is the first alkyne. Similarly, let us write the next 2 members like we have done for alkenes and alkenes. N is equals to 3 would be C3H 2n minus 2. So C is 3, 2 into 3, 6 minus 2 is 4. So the formula would be C3H4. Write down the 3 carbon atoms, join them using 1 triple bond. 1 triple bond has to be there, and add the hydrogen atoms. This carbon is already bound to 3 valencies. It has 1 valency free, which means 1 hydrogen atom can be added here. This carbon atom, it is already filled because 1, 2, 3, 4. You cannot add any hydrogen atoms to the second carbon atom, and the third carbon atom is only bound to 1, which means it can take 3 more. So we can add 3 more hydrogens, and 1, 2, 3, 4. 4 hydrogens are present. Done. 1, 2, 3. 3 carbons are present. There is a triple bond and valencies of carbon, it is 4 everywhere. Right? The valencies are completely filled everywhere, which means the structure is correct. Name, because there are 3 carbon atoms, the name begins with a prop. Because it is an alkyne, the name would be propyne. So that is how we can write the structures of alkynes. Let us do one more. The third member would be having 4 carbon atoms. So the formula will be C4H6, and write down the structure. 1, 2, 3, 4 carbons in a straight line. Join them using bonds, and one bond has to be a triple bond, has to be, and add the hydrogen atoms. So 1 hydrogen atom can go here. This is already filled. This can take 2 more, and this can take 3 more. So 1, 2, 3, 4, 5, 6. 6 hydrogen atoms are present, 4 carbon atoms are present, triple bond present, and valence is done. The name, because there are 4 carbon atoms, it will begin with the but. And because there is a triple bond, it is alkyne, name would be butane. So that is the third member of the alkyne family. Similarly, you can practice writing the structures for n equals to 5, n equals to 6, n equals to 7. Just for practicing writing the structures of the alkane, alkene, and alkyne. You have to follow the exact same pattern. So in these 2 cases, alkenes and alkynes, these 2 hydrocarbons, they are called as unsaturated hydrocarbons together. Unsaturated hydrocarbons. So if you are to ask to define unsaturated hydrocarbons, these are hydrocarbons containing double bond or triple bond. In that case, they would be called unsaturated hydrocarbon. Example, alkene and alkyne. Whereas saturated hydrocarbons are those which contain only single bond. Example, alkane. Because they have double bond and triple bond available, these are comparatively more reactive than the saturated hydrocarbons. These are more reactive. Why? Because if you remove this one bond, let us say, it makes one valency available. So we can add another something. Let us say some element we can add and it will change the compound. So that is what makes them reactive. In the case of alkynes, we can remove two bonds. So we can add some more additional atoms here, making them reactive. So saturated hydrocarbons are less reactive, whereas unsaturated hydrocarbons are more reactive because they have double or triple bond present. That is all about the hydrocarbons. Hydrocarbons are saturated and unsaturated. Saturated hydrocarbons are called alkanes. They contain single bond only and they have the general formula CnH2n plus 2. Unsaturated hydrocarbons could be alkene or alkyne. They contain at least one double bond, whereas unsaturated hydrocarbons, that is alkynes, they contain one triple bond at least. So that is about the hydrocarbons, and we also learned how to write the structures of the different members of these hydrocarbons and the criteria for naming the hydrocarbon. One carbon name will begin with the meth, 2 carbon begins with eth, 3 carbon prop, 4 carbon but, 5 carbon pent, 6 carbon hex. And if it is alkane, the suffix ane will be added to the end. If it is alkene, it will end with the ene. If it is alkyne, it will end with the ine. In the next class, we will study carbon compounds other than hydrocarbons. Thank you.